Assalamu alaikum wa barakatuh. Today, inshallah, we're going to solve question number 9 from the IB documents I shared with you on Google Classroom. The same question you had in the exam yesterday. So here we have a magnetized needle is oscillating on a string about a vertical axis in a horizontal magnified field B. The time for 10 oscillations is recorded for different value of B. So we have a string and there is a needle. The needle is hanged in a magnetic field and the needle is oscillate back and forth. Okay, there is a relationship between the magnetic field, the value of magnetic field, and time for 10 oscillation on y-axis. Now the graph shows the variation with the value of the magnetic field B for 10 oscillation. The question is that the uncertainty in B is negligible. So as you see here, we don't have error bars in x-axis. So the uncertainty in B is the magnetic field, is ignored, and here we have time for 10 oscillation. Now the question is, draw on the graph the line of best fit for the data. The line of best fit not necessarily to be a straight line, but it should pass through or touch all the error bars. So when you draw a smooth line that touch all the error bars. Now, write down the time taken for one oscillation when B equals 0.005 Tesla. T, it's a unit. Tesla, we call it Tesla for the magnetic field. Okay, with the absolute uncertainty. Now we'll go back to the graph. At 0.005, here, you draw a straight line till it reach the point here, and then you read the value of this point. Okay, now how can I find the value of this point? Here I have from 4 till 5, it's 1. And I have 1, 2, 3, 4, 5 squares. So 1 divided by 5, it will give me 0.2. So each square is 0.2. So this value here I have, this is 8 plus 2 squares. 2 squares, so it will be 8.4. So this is the time for 10 oscillation. This is the time for 10 oscillations. So I'm going to write here the time for 10 oscillation is 8.4. The question is, what's the time taken for one oscillation? So I need for one oscillation, what will be the time taken? Okay, so you do cross multiplication. This is a propagation. So if I do cross multiplication, 8.4 times 1 divided by 10. So time for one oscillation will be 8.4 times 1 divided by 10, and this will be 0.84. The unit is second. This we call it the period. Okay. Time it will take to complete one oscillation, because the needle is going back and forth. The time to complete one oscillation, we call it the period. You're going to study it in details when you study waves. Now I need to find the uncertainty. We know the uncertainty is the length of the error bar. Now if you look here, I have 1 square and half. 1 square is point, we said is 0.2, yeah, which means 0.3. This is the length of the error bar. The length of the error bar. Okay, so let me delete this one to see. This is the length of the error bar. So it's around 1.5 square. We said 1 square is 0.2, so 1.5, it will be 0.3. Again, this is 10 oscillation. So 10 oscillation, I have 0.3. So 1 oscillation, what will be the uncertainty? Again, cross multiplication, 0.3 times 1 divided by 10. So the uncertainty for the time, I'm going to call it T or the period, will be 0.3 divided by 10 will be 0.03. So to write now the time, I can write it as T, or the time will equal 0.84 seconds, positive or negative, the uncertainty part, which is 0.03 seconds. Okay, now C, you have a student forms a hypothesis that the period of one oscillation, now he give the period a simple P. P equals K is constant divided by square root of B. B, it's the magnetic field. Determine the value of K using the point at B equal 0.005 Tesla. So I need the value of K from this formula. Okay. So K, just do cross multiplication, will be P times square root of B. Okay. P is the period. P is the period of one oscillation. We calculate the period of one oscillation to be 0.84. So this will be 0.84 square root of 0.005. And this will be 0.059. Okay, this is K. This is the value of K. Now, state the uncertainty in K to an appropriate number of significant figure. Okay. Now, the uncertainty from the formula. We said P is 0.005. So this number is constant. So I can write it K equal constant, which is 0.005 times P. I need now, we're going to use the propagation uncertainty. Constant, we ignore it. When we calculate the uncertainty, if you have a constant number, you ignore it. And since you have multiplication, so you find the fractional or percentage uncertainty. So it will be the uncertainty in K divided by the original equals, this one you ignore it, the uncertainty in the period P divided by the original. I need the absolute uncertainty, so delta K, just substitute, divided by the original value of K, which is 0.059, equals the uncertainty in the period. We've just calculated the uncertainty in the period. It was 0.03 divided by the value of the period. Time for one oscillation was 0.84. Now cross multiplication. So delta K will be 0.03 times 0.059 divided by 0.84. And this will be equal to 0.002. This is the uncertainty in K. Now state, next section D, state the unit in K. Okay, also from the formula, always the unit from the formula. We said K, it's P, which is the period, times square root of B, which is the magnetic field. Period is time. period is time. So the unit is second times B, it's a magnetic field. So if you go up, you see B in Tesla. Always when you look at the graph, the unit is there. P, the unit is T. T, this is a unit, Tesla. So time square root of T. So the unit for K will be S times T Tesla to the power half. Unit, this is the unit of K. Okay. Next, 9E, you have a student plots a graph to show how P square varies with 1 over B. Okay, we'll go to the original relationship is given to you. This is the original relationship. P, the period, equals K divided by square root of B. So if you square both sides, will be P square equals K square divided by B, because the square root with the square will be cancelled. Now this is linearization. We studied the last lesson in uncertainty before we study the vectors. This one will be drawn in y-axis. This one will be x-axis. So this will be the slope. Okay. So you have y, you have x. So you should be the straight line start from 0. Okay. The slope of this straight line will be k squared. So the equation will be p squared equals k squared times 1 over b. So the slope state how the value of k can be obtained from the graph. K squared will represent the slope. I need k, take square root for both sides. So k will equal square root of the slope. Square root of the slope. That's it. That was your exam question yesterday.